Hello, Paul and Ryan. I'm just going to do a quick video just to show you how to set up this Derrytrasna tank. I know, Ryan, we had discussed a few different options, the most critical being the FE surface vertical walls and then generating loads and being able to copy them across. So there's an alternative way of doing it as opposed to the area loading that we had been doing before. So we're going to use a slightly different way of applying these loads, but it means we can more quickly, more effectively set up our model. So if we say, let's create a new tank, okay, there, just a tank. And we're going to set up an array and an FE surface and then copy that around. So rather than using the grid lines that we've done before, you have this video for future reference as well. So just say dummy member, and we're going to start at not, go out 5.15 and then go up, I think at 1.955, 1.955. Hopefully that's vertical. Yep. So create, we're going to copy that around once. So we'll do that. Rotate one copy, and we're going to go 5 degrees, and we're going to pick the origin as that. So if we went around 71 times and create connected members, we can see we've got our tank there. I'm going to go around once, and then I'm going to copy that around 70 odd times, and let's see if we go -5. Okay, so let's create that surface. I'm going to go under FE surface module, add one, use those boundaries. Openings, non-edge support conditions, nope. Material thickness, we can go on and say we're using a 300 thick concrete, 285, that's 2535. Loading. So this is going to be the loading. So let's just we're going to create 3 loads in this. So our surcharge load, we're going to say that's a live load. So scroll down to L1, it's going to be normal to the face of the surface, and we're saying 5 kilonewtons. We're going to add a new load. Instead of an area load, we're going to use a patch load, and we're going to say it's D1 normal to the face of the surface, and we're going to say 17.700, and we're going to say a varying load, and we're going to specify load points here. So we're going to create 6 load points. So instead of nodes to reference for the application of our loads, we're going to use these load points, which are specific to our points, lines, and patch loads. So let's say 1, 2, we're going to go up 1.805 for 3, and then across we're going to say, well, just go reference here as well, 1.805. and then 3, 4, 5, and 6. Okay, that's our load points done. We can use these as references now for our loading onto the face. So if we did need any more at different levels, we can just input those now or later, doesn't really matter. The load points, the varying load points, we're going to go from 1, 3 to 4. So 1, 3, and 4, they coordinate with the different values that we've got there. And now we have to define the outline of our loads for this particular patch load. So we've got our load points set up. We can use those for multiple patch loads, and within here we're going to specify the outline of that. So it's going to go all the way 1, 3, 4, 2, 1 as I've specified there. So that hopefully makes sense. Now we can copy that and paste it and scroll down to the one we've just created. Change that to D2. We're going to go in the opposite direction, 3.3, and instead of 3 and 4, we're going to go 5 and 6, and again 5 and 6. Okay, so that's our load setup. I know there's some surfaces that aren't loaded externally, but you can amend those later. But once we've got it set up now, we can copy that across. So create, copy, select this surface, or I think we said 71 copies before. Rotate on plan at 5 degrees. Pick 71 copies at an angle of 5 degrees and apply. So let's just make sure that we've got this done right. Edit FE surface. Let's see how many surfaces we've got. 72, 71, 72, 1, 2. So that looks good. We can then add a new just okay. That's fine. Material thickness, again, it's going to copy across that edge support conditions. We're going to say 10,000 compression only. We'll need to do our notostatic supports. Let's see, others, X, direction, and then add, I'll make that Z, add X. I'm going to change these down here, make sure that we've got those in the right place. That should stop it spinning around. And then load cases, we can say internal forces, external forces, and then we can just change these. Delete this load case, delete, yes. So we've got the title set up, and then we can just change our load combinations then. So for internal, it's 1.35, 1.35, delete, external forces, 1.35, 1.35, 1.5. Now I'm just going to make sure that we've got our, I'm just going to double check our self weight, so it's under D1, so just make sure that that's, we can change that to D not actually, for just to separate those out, and then hopefully this analyzes. Oh no, I'm going to set up my FE surface meshes first. So mesh to this, so this is a stiff region, so this is to make sure that the wall and the slabs sort of don't, you're not getting any peaks there, so it takes the thickness of the slab and the thickness of the wall and generates a mesh based on that. The length there, I think it's per, so it's 0.449, so we'll just say go halfway across that 0.225. Global meshing options, not 0.225. Okay, then we can see how that mesh looks when we generate it. So you'll be able to see the stiff regions being set up there for the thickness of the wall and the slabs there, and that should be okay. So we'll do the results, graphical analysis results. I'm actually going to set up another couple of load cases for us. and add service case to all cases, and then it's good practice to check those frame loads then, just to make sure that they're all acting in the same direction. There's one that's not maybe the original one that we have set up. I'm just going to go in and review that. So FE surface 1, loading, I'll maybe swap the local Z direction just to make sure that it's done right. Something might happen when I was copying it across. So if I review those loads again, that looks to be good. Internal, external forces. Whoops, I think they're back to front there. So if I want to change that, modify, edit, go to loading, and then I can edit these globally. So if I go down D1, I can change that now to minus, and D2, change that to positive. So just the global editing function there will be very useful as well. And as I say, Ryan, before we were using the node points, but now we're using the local load points. So you can change those. If you need to, you can add to them and you can amend them if you did need to take that water level down a bit, and that can all be done within here. So let's analyze. Hopefully we don't get an error with the analysis. That's good. So results, graphical analysis, results, and then we go to our shell, contours, stresses, and tau 1 principle. So that's what we were looking for, I think, first time around. So if I ignore the base on that, finite element surface filters, and I take out the slab, then we can get hide selected. We can just see our walls for our different load cases, internal, external, and then serviceability, and for both of those, now we can show our different contours there as well. So, and as you see, it's ignoring this slab thickness here, so we're not getting any peaks there. Yep, okay, I'm gonna send this to you, and then sure we can get caught up at some stage when you guys are free. Okay.